Now let's discuss handling missing data. So the difference between data found in many tutorials and data in the real world is that real world data is rarely clean and homogeneous. In particular, more interesting data sets will have some amount of data missing. So to make matters even more complicated, different data sources may indicate missing data in different ways. In this lecture and in a couple of lectures, we will discuss some general considerations for missing data, discuss how Pandas chooses to represent it, and demonstrate some built-in Pandas tools for handling missing data in Python. Here and throughout the course, we'll refer to missing data in general as null, NaN, or Na values. Here. So now let's discuss trade-offs in missing data conventions. A number of schemes have been developed to indicate the presence of missing data in a table or data frame. Generally, they revolve around one of the two strategies. The number one is using a mask that globally indicates missing values, or choosing a sentinel value that indicates a missing entry. So in the masking approach, the mask might be an entirely separate Boolean array, or it may involve appropriation of one bit in the data representation to locally indicate the null states of a value. So in the sentinel approach, the sentinel value could be some data specific convention, such as indicating a missing value, missing integer value minus with negative 9999, or some rare bit pattern. Or it could be a more global convention, such as indicating a missing floating point value with the NaN, or not a number, or a special value which is a part of the IEEE floating point specification. So none of these approaches is without trade-offs. Use of a separate mask array requires allocation of an additional Boolean array, which adds overhead in both storage and computation. A sentinel value reduces the range of valid values that can be represented and may require extra, often non-optimized logic in CPU and GPU arithmetic. Common special values like NaN and are not available for all data types. So, and in most cases where no universally optimal choice exists, different languages and systems use different conventions. Let me give you an example. The R language uses reserved bit patterns within each data type as sentinel values indicating missing data, while the SciDB uses system that uses an extra byte attached to every cell to indicate NA state.